Okay, pre-cal students, welcome to the homework help video, page 491, and here we go. Number 7, let's solve these exponential equations. Remember, whenever you can take a exponential equation and write both sides with the same base, then you need to do that. So I have 4 to the x power, and of course we can write 16 as 4 squared. So anytime you can write both sides of the equation with the same base, then do that, okay? So we have a base 4 here, base 4 here, cross them off, x equals 2. Okay, number 9. Number 9, here we go. Alright, let's see, 625 can be written with the base of 5. So let's see here. 5 times 5 is 25, times 5 is 125, times 5 is 625. So 5 to the x power equals 1 over 5 to the 4th power, because 5 to the 4th power equals 625. Now bring this up top here like this, and we have 5 to the x power equals 5 to the x power equals 5 to the negative 4 power. Notice the 5 does not change, just the 4 changes, okay? So we have both sides with a base of 5. Cross off your 5s and x equals negative 4. Okay, moving on to number 11. Alright, here we go. Both of these can be written with a base of 3. So for 27, I would put 3 to the 3rd power, and then right here is your x, right here. So we put that x right here, okay? And then for 9, I'm going to put 3 squared. Now, whenever you have a power raised to a power, you multiply your exponents together, 3 times x. So you'd have 3 to the 3x power equals 3 squared. And now look, we wrote both sides with the same base, 3. Cross off your base, and you have 3x equals 2. Divide both sides by 3, and x equals 2/3. Okay? All right, number 11. All right, here we go. Or number 13, excuse me. Okay, 1/2 and a 32. Well, here's what I'm going to do. Now watch this carefully, guys. I'm going to put 1/2 to the x power, okay? Now next, I'm going to put 32 to the, or excuse me, 2 to the 5th power. Now somehow I've got to get both these sides written with a base of 2. So how am I going to do that? Well, here's what I'm going to do. Watch this carefully. First of all, I'm going to go ahead and take my x and multiply it through. There's a 1 here, right? 1 to the 1 power and 2 to the 1 power. So take your exponents and multiply them times the x. So 1 times x is 1x. And 1 times x is 1x. Okay? So look that over. See if you have any questions, okay? If you had 1/2, if you had something like x squared over y to the 3rd, that whole thing to the 5th power like this, it would take 5 times 2, and you would take 5 times 3, and you would have x to the 10th over y to the 15th. You would multiply your exponents, okay? And that's what I did over here. My powers were 1 and 1. So 1 times x is x, 1 times x is x. Now, anything 1 to any power is 1. I don't care if it's 1 to negative 30. It's 1. I don't care if it's 1 to the positive 3,000. It's 1. So I don't care what x is. 1 to any power will always, always, always be 1. So my whole numerator here is 1. Okay? Now I've got 2 to the x. Now guys, take your 2 to the x and bring it up top. You can do that as long as you put what? 2 to the negative x. You can do that. And then, hold on one second here, students. Let me fix my book here. And then bring down your 2 to the 5th. And look at that, guys. We're good. Okay? So cross off your like bases. Negative x equals 5. So if negative x equals 5, divide both sides by negative 1. And x equals negative 5. I better start checking the back of the book on these, make sure we're doing them right. I'm pretty sure we are, but let's make sure here. What do we get so far before I erase the other one? So 2, negative 4. Hold on one second here. Okay, everyone that we've done so far has been correct. I've checked them all. Okay, moving on. So the answer here is negative 5. Okay? All right, number 15. Now again, once again, whenever you can write both sides of the same base, do that, okay? So we have 3 force x equals, let's see, we'll go into both of those numbers. Maybe nothing. Okay, we cannot write both sides with the same base. We cannot. So you look at your unknown, and your unknown is right here with x. Okay, right here's your unknown with 3/4. So the base of your unknown is 3/4. So we're going to take log of, or log base 3/4 equals log base 3/4. Okay, and then you take the entire left side and you put it right down here. Okay, and you take the entire right side and you put it down here. There we go, moving right along. Now, whenever your base matches your base, the entire expression equals your exponent, so x. So x equals log base 3/4 of 27 over 64. So here's what you type into your calculator. You type in log of 27 24ths, divided, put parentheses around it, divided by log of 3/4. Okay, let me get my calculator real quick and do that. Log of 27 divided by 24, or 27 divided by 64, sorry about that. 27 divided by 64 divided by log of 3/4. And we will get 3. And so the answer is 3. Okay, let's check the back of the book real quick, make sure we're right. Yep, moving on. Okay, number 17. All right, we have 3x minus 1 equals 27. Now, and by the way, on that last problem, I really messed up because you could write both sides with the same base. Look, 3/4 to the x equals 27 is 3 to the third power. And 64 is 4 to the third power. And then you could do this, you could pull that 3 out and just put 3/4 to the what power? 3 power, x equals 3. Anyways, either way it works though. So, okay, number 17. 3 to the x minus 1 equals 3 to the third. 27 is 3 to the third. So we've written both sides with the same base, cross off your like base, and we have x minus 1 equals 3. Okay, bring the 1 over and make it positive. X equals 4. That's number 17, and we are correct. Moving on to number 19. Okay, natural log problem here, so here we go. Here's what I taught you when you're solving logarithmic equations. If you have 2 logs on one side like this, go ahead and put them together. So we have natural log. The 2 logarithms are subtracting, so x over 2 equals 0. Okay? Now, after you've done that, don't forget your base here is an e. So next, you write the expression exponentially. So you would have x over 2 equals e to the 0. Okay? And anything to the 0 power is 1. So now you have this. And then multiply both sides by 2, and you get this. So there's your answer. Now, whenever you're solving a logarithmic equation, don't forget to take your answer and put it back into your argument, and make sure you have a positive argument. So for this x right here, I'm going to put a 2, and my argument is positive, so I'm fine. Okay, moving on to number 21. Number 21. Okay, here we have an exponential equation. There's no way you can write both sides with the same base. So what is the base of your unknown? E. So we're going to take log base E of one side and log base E of the other side. Okay, so bring this down. Bring this down over here. And there we go. Whenever your base matches your base, the entire answer is your exponent. So we have x equals, and then log base E is natural log of 2. So let me grab my calculator here. The natural log of 2 is 0.6931. 0.6931. Okay, moving on. That's number 21. Make sure that's correct. And yes, it is. Okay, number 23. 23. Here we go. Okay, we're solving a logarithmic equation. And look, guys, the log's already isolated for you. You have a natural log of x, which is log base e of x, equals -1. So write it exponentially. X equals e to the -1. So type e to the -1 into your calculator, and you will get the answer, which is 0.368. If you round correctly, 0.368. Okay, moving on to number 25. Number 25, here we go. Okay. Once again, students, we have one logarithm all by itself. So let's go ahead and write it exponentially. So we'd have 16 equals x to the 4th power. Okay? Now, guys, we know how to solve this. You take the 4th root of x to the 4th. But if you take the 4th root of one side, you must take the 4th root of the other side, like this. Okay? So the 4th root of x to the 4th is x, and the 4th root of 16 is 2. Now, if you don't know how to do a 4th root on your calculator, here's how you do it, okay? The first thing you do is you push math button, okay? Math. So push your math button, okay? Then look at option number 5. Well, actually, I'm wrong. Start over again, okay? The first thing you do is you type in 4. Okay, so hit 4 on your calculator. Then hit math, okay? Then hit option 5. And this should appear on your screen. And that does not mean 4 times this root. It means your 4 is right here. So now type in 16. Okay? Hit enter, and you will get 2. Okay, so 2 equals x, but hold it. Listen, guys, whenever you choose to insert the radical into an equation, if it's an even index, square root, 4th root, 6th root, whatever, you must put plus minus into the equation. So put plus minus here. So there's your answers. But hold it. Remember, with the logarithm, you've got to make sure that both answers work. Okay, it's very important. So be very careful here. All right. When you go to check both answers, you will see that positive and -2 both work. They both work. No, I'm not sure why the back of the book has 2 only, but -2 is also an answer. Okay? You can also have -2 for an answer. It's totally fine, okay? So moving on to number 27. Number 27. Okay, here we go. Alright, now we have one logarithm. So get that logarithm all by itself. So here we go. Log base 10 of x equals 2. Bring the 2 over, make it a positive 2. Okay, now write the problem exponentially. So x equals 10 to the 2. So x equals 100. And if you check that, it does work. So the answer is 100. Okay, number 29. Log base 1/2 of x equals a -3. Okay, so x equals 1/2. I'll be sure and put the parentheses, the fraction in parentheses, 1/2 to the -3 power. So with your calculator, type that in. I would type in parentheses 1 divided by 2, then arrow, and then -3. Okay? And if you type that in correctly, you will get 8 for your answer. And that does work in the equation. So your answer would be 8 for number 29. And I'm checking that now, and that's correct. Okay, moving on. Okay, now let's see what the directions say here for this problem. Okay, students, on number 31, what they want us to do is approximate the x answer here by estimating the answer right here. So that ordered pair where the two graphs intersect, that ordered pair would be 3, 5. So this is your x, and this is your y. So x equals what? 3. Then they want you to solve it analytically. So here's what we're going to do. We take the two equations and we set them equal. So 2 to the x equals 8. 2 to the x equals 2 to the third. So what does x equal? 3. So there we go. Now same thing down here. We're going to approximate the point of intersection, which will be right here. 9, 2. And this is your x, and this is your y. So it looks like x equals 9, okay? Now let's set these two equal, and let's solve it analytically, okay? So log base 3 of x equals 2. Okay, we're going to write that exponentially. So x equals 3 squared. So there it is. X equals 9, okay? All right, let me check those in the back of the book, and we are moving on. Here we go. Number 35. Okay, let's solve these very quickly. Or I think the directions say to solve or simplify. But here we go. This one's pretty easy here. Whenever the base matches the base, then your answer is the exponent. So the answer would be x squared. Okay? Number 37. Now, whenever the base here matches the base here, your answer is the argument. And the argument is x minus 2. So that would be your answer. Okay, moving on. Here, okay, remember when it's a natural log, right here, you can rewrite that like this. Log base e of e to the 7x plus 2. Okay, so there we go. So whenever your base here matches your base here, the answer is the exponent. So your answer would be 7x plus 2. Right, number 41. Okay, we have e, and then look at your exponent. It's a natural log. So for this natural log right here, I'm going to put log base e of 5x plus 2. Because that's what natural log means. That means log base e. Now, whenever your base here matches your base here, then the answer is your argument. So the answer would be 5x plus 2. Okay, there we go. All right, moving on. All right, this one here, let's see what we can do with this one. You have negative 1 plus log base e of e to the 2x. Because this natural log right here means log base e. So this base here matches this base here, so your answer is the exponent. So you have negative 1 plus 2x. And that should be the answer. And yes, in the back of the book they had, well, hold on one second, guys. I'm looking at number 41. And I don't think we got 41 right. Let's see here. Okay, guys, I'm back. 41 was fine, but moving on to 43. The back of the book had this here for the answer, which is the exact same thing. Okay? Alright, number 45. Okay, here we go. We're going to solve this equation. So we have, there's no way we can write both sides with the same base, okay? There's no way. So the base of my unknown is e. So I'm going to write log base e. Log base e. I'm going to put e to the x and 10. Okay? So when a base matches a base, The answer is the exponent. X equals log base e, which is natural log of 10. So here we go. Natural log of 10 would be 2.303. And that is the correct answer. 2.303. Okay, moving on to number 47. Here we go. Okay, now notice I have my base here's e, and I want to get that all by itself, okay? So here we go. Negative 2 e to the x equals, bring the 7 over, make it a negative 7, so negative 2, okay? Now, divide both sides by negative 2. These cancel, and you're left with e to the x equals 1. Now, students, think about it. You can do this the long way if you want to, by taking a log base e of both sides. That's fine, okay? But there's really no need to, because look at your problem here. What is the only thing that you can put in for 0 for x that would solve this equation? 0. E to 0 is 1 power. There's no other number that x can be. X has to be 0. Okay? So, e to the 0 equals 1. So, x has to be 0. Now, you can do it the long way if you want. That's fine. Like this. Take log base e of both sides. Here your base matches your base. X. And then natural log of 1 would be 0. Type that in your calculator and you'll get 0. So x equals 0. Okay? And that is the correct answer. Alright, number 49. And here we go. Alright. E to the 3x equals 12. There's no way we can write both sides with the same base. So log base e. Log base e. Bring down your e to the 3x. Bring down your 12. Over here, your base matches your base. So you're left with 3x equals log base e is natural log of 12. Okay, divide both sides by 3. And x equals natural log of 12 divided by 3. Now, students, when you type in the natural log of 12, be sure and hit enter. So natural log of 12, enter, divided by 3, enter. And you should get 0.828 for your answer. Okay? Moving on to number 51. Okay, 51. Well, first of all, guys, you want to get e to the negative x by itself. So, we're going to divide both sides by 500. Okay? So we get e to the negative x equals 0.6. Now, there's no way we can write both sides with the same base. So we're going to take log base e of both sides. So here we go. Okay, your base matches your base. Cross those off. Negative x equals natural log of 0.6. Now divide both sides by negative 1. X equals natural log of 0.6 over negative 1. Okay, so very quickly here, natural log of 0.6, enter, divided by negative 1, enter, and I'm getting 0.511, which is the correct answer. 0.511. Okay, alright, moving on to number 53. Now this is the ones here, guys, where we're going to have to use the quadratic, rewrite it like it's a quadratic equation. So here we go. We're going to say that e to the 2x is the same thing as, let's see, e to the x squared minus 4 times e to the x minus 5. Okay, then we're going to say that u equals e to the x. Okay, so we're going to put u squared minus 4u minus 5 equals 0. Okay, now thankfully we can factor this one. So u minus 5, u plus 1. Okay, when you multiply these together, you get negative 5. And then if you combine your like terms, you will get a negative 4u for your middle term. So now continuing on for u right here, u minus 5 equals 0, and u plus 1 equals 0. Now where the u is, I'm going to put e to the x. So e to the x minus 5 equals 0, and bring the 5 over, make it positive. Now take the log base e of both sides. So log base e, log base e. Of course, these here cancel out. X equals natural log of 5, so x equals 1.609. Okay, so that's one answer so far. Now, this one here is going to give you no solution. Okay, let me show you why. Okay, for u, I'm going to put e to the x, and bring the 1 over, make it a negative 1. Okay, now take the log base e of both sides. And right there it fails. You cannot take the logarithm of 0 or a negative number. So there is no answer to this equation here. Okay, you cannot take the logarithm of a negative number. So no solution for this part here. So this is your only answer. Okay? Alright, moving on to number 55. And here we go. Let's see, we want to get this base here all by itself. So divide both sides by 20. Okay, and we're left with 100 minus e to the x over 2 equals 25. Next, bring the 100 over, make it negative 100. So negative e to the x over 2 equals negative 75. Then divide both sides by negative 1 to get e all by itself. And now we're good. the base of your unknown is e, so log base e of e to the x over 2 and 75. Okay, your base matches your base. X over 2 equals, remember log base e is natural log. Okay, multiply both sides by 2. And now you're all done. Take your calculator and type in 2 natural log 75. Enter. And you should get 8.635. Okay. Alright, moving on. Number 60 or 57. Number 57. Okay, we have an exponential equation here. There's no way we can write both sides with the same base, so we're going to write log base 10. The base of my unknown is 10, so log base 10 equals log base 10 of 10 to the x and 42. Okay, so whenever a base here matches a base here, your answer is the exponent. And of course, log base 10 is just log of 42, which your calculator does for you. So, type into your calculator log of 42, and you will get 1.623. And this should be the answer to number 57. And it is, yes. Okay, moving on to 59. Okay, 59. There's no way you can write both sides with the same base. Okay, there's no way. So the base of my unknown is 3. So I'm going to write log base 3 equals log base 3 to the 2x equals 80. Okay, there we go. Now whenever your base matches your base, the answer is your exponent. So 2x. And then over here, our calculators do not do base 3, but we can rewrite it like this. Log of 80 over log of 3. Okay? And then get that into a decimal. So 2x equals, let's see, log of 80. Enter, divided by log of 3. Enter. I'm going to put about 6 decimal places. 3.988. 629. 692, sorry. Divide both sides by 2, and you will get 1.994. Okay? And let me check the answer in the back of the book. That is correct. Moving on to number 61. Okay, 61. Here we go. Alright, there's no way we can write both sides with the same base, so the base of my unknown is 5. So log base 5, log base 5. Okay, 5 to the negative t over 2, 0.20 over here. Well, whenever your base matches your base, the answer is your exponent. So negative t over 2 equals, of course here we have log of 0.20 divided by the log of 5. So now I would have negative t over 2 equals, grab my calculator real quick, log of 0.20, enter, divided by log of 5, enter, and you get negative 1. Okay, negative 1. Now multiply both sides by negative 2. Because of your 2 here and your negative sign here, multiply this side here by a negative 2. Multiply this side here by -2, and you will get t equals 2. Okay, let's check the back of the book. And that is correct. Number 63. Okay, here we go. There's no way we can make both sides with the same base. So the base of my unknown is 2. So here we go. Log base 2. Here we go. Log base 2. Okay, whenever your base matches your base, the answer is your exponent. So 3 minus x equals log of 565 divided by the log of 2. Okay, so here we go. Log 565, enter, divided by the log of 2. Okay, now bring the 3 over and make it a -3. And then divide both sides by a -1. And x equals 6.142. Okay, let's check the back of the book here real quick. And that is correct. Okay, moving on. Number 73. Okay, same problems. Here we go. Okay, the base of my unknown is 10. So I want to get this whole base, this whole exponential, isolated. So I'm going to divide both sides by 8. So divide both sides by 8, and you'll have this. 10 to the 3x equals 12 divided by 8, which is 1.5. So 10 to the 3x equals 1.5. Now the base of my unknown is 10. So log base 10 of 10 to the 3x and 1.5. Okay, your base matches your base. So your answer is just 3x equals, now log base 10 is just a regular log, common log of 1.5. Now divide both sides by 3. So x would equal 0.059. And that's number 73. Okay, moving on to number 75. Same thing. Here we go. Divide both sides by 3. Okay, the base of your unknown is 5. So log base 5. Log base 5. Here your base matches your base. Okay, type this into your calculator, bring the 1 over, make it a +1, and you get 2.209. That's number 75. Okay, moving on to number 77. Okay, now students, on this one, my suggestion is to get this entire base here into a decimal. Okay, so I'm going to take with my calculator 0.065 divided by 365, enter, and then plus 1. And I'm going to get this right here. And I'm going to make it pretty big, okay? 1.0001781. Okay, to the 365 t power. Okay, there we go. Now the base of your unknown is this right here. So the logarithm okay, so we have log base this right here of this entire expression here equals the log of and the 4 goes here. Okay, so here we go. Now when a base matches a base, the answer is this. Okay, there we go. Okay, log base 4, enter, or log of 4, enter, divided by log of 1.00018, enter. And you'll get this right here. Divided by 365, and you'll get this right here. Okay. Now let me check the back of the book real quick here. See if that's right. Yes, it is. That is correct. Okay, moving on to number 79. Here we go. Okay, same thing. I would type this whole thing here into a decimal, okay? So here we go, 0.1 divided by 12 equals plus 1. Okay, and here's what I get. .008 and 3 repeating to the 12t power. So the base of my unknown is this right here. So log base 1.0083 okay, your base matches your base. So your answer is your exponent, 12t, log of 2 divided by log of 1.003. So very quickly, let's see what that is. Log of 2 divided by log of 1.0083. So we get this. 12t equals 83.8578. 0464 divide by 12, and t equals 6.988. Okay, there we go. Let's check number 79 real quick in the back of the book, and that is correct. Okay, moving on to number 81. Okay, we want to get the base of the unknown here all by itself. So here's what I would do. I would multiply both sides. Well, I'll tell you what would be easier to do is this. I would put 2 over 1, and I would flip this side here, which you can do as long as you flip the other side. Okay? Now multiply both sides by 3,000, and you'll get this. Okay? Now bring the 2 over, make it a negative 2. And now take the log base e of both sides. Your base matches your base. So you're left with 2x equals the natural log. Log base e is natural log of 1498. Divide by 2, divide by 2. Okay, here we go. The natural log of 1498. Enter, divided by 2, enter 3.656. Rounded, of course. Okay, let's check that in the back of the book real quick here, and that is correct. Okay, moving on. Okay, let's solve some logarithmic equations. Remember, in these problems, you need to check your answers, okay? So here we go. Okay, the logarithm here is already isolated. Okay, so we're going to write the problem exponentially. So it'll look like this. There's a base e here, even though you can't see it. So x equals e to the negative 3. So x equals 0.050. Okay? And that does fit. That does work in for x right here. Okay? Alright, number 85. Here we go. The base is e. The logarithm is isolated. So here we go. 2x equals e to the 2/4, or to the 2.4. Now divide both sides by 2. And if you take your calculator, type in e to the 2/4 power, enter, divided by 2, enter, you will get 5.512. 5.512. Okay? Moving on to number 87. Here we go. Okay, notice here the logarithm is not isolated. We had to divide both sides by 3. Okay? So natural log of 5x equals 10/3. Now the logarithm is isolated. The base is e. So 5x equals e to the 10/3 power. Divide both sides by 5. And we get this right here. Okay? Alright, so with my calculator, if I were to type in e to the 10th third, enter, divided by 5, enter, I would get, let me check and see here, I would get 5.606. Okay, which is the correct answer. Okay, moving on to number 89. Okay, the logarithm is all by itself, okay? Base e, so I would have this. Now, in order to get rid of a square root, you must square this whole, you must square it. But if you square one side, you must square the other side. So when you square a square root, you get what's on the inside. When you square e to the 1, you get e squared. 2 times 1 is 2. Now bring the 2 over, make it negative. And if you take your calculator and type in e squared minus 2, you will get 5.389. 5.389. Okay? Alright, moving on to number 91. Okay, here we go. Okay, natural log of. Okay, notice we have two logarithms here. There's a log, here's a log, and they're being subtracted. Okay, so let's condense them down to one logarithm, like this. Natural log of x minus 2 divided by 3 equals 2. Don't forget there's an e right here. So next we have x minus 2 over 3 equals e to the second power, okay? Now multiply both sides by 3, and you're left with this. Then bring the negative 2 over, make it a positive 2. And if you type that into your calculator, you will get 24.167. Okay? Alright, number 93. Remember, guys, we're just doing the odds, okay? Just the odds. So here we go. Now here in 93, we have two logarithms being added, okay? So we have the natural log of 2x minus 1 times 2. So you would get 4x minus 2 equals negative 2. Now I hope everyone sees where this came from right here. 2 times 2, or 2 times 2x, 2 times negative 1. Okay? There's an e here. So now we have this right here. Okay? Now bring the 2 over, make it a positive 2. Okay? And now divide both sides by 4. Okay, so we get this. So with your calculator, if you typed in e to the negative 2 plus 2, enter, divided by 4, enter, you will get 0.534. Okay. There we go. Okay. All right, number 95. Okay, notice we have two logarithms being added, so we're going to multiply their arguments. Natural log of x squared plus x squared minus x equals 1. Okay. Now, let's see, here's a base e. So x squared minus x equals e to the 1. Now, this is going to be really tough to solve, okay? Don't forget, guys, e to the 1 is a number. Okay, so we have a number here. Now look, if you had a quadratic equation like this, x squared minus x equals 11, you know how to solve that. You would bring the 11 over, make it negative, and then use the, you can't factor that, so you would use the quadratic formula. Okay, well, 11 is a number right here. Well, guys, look, e is a number, okay? So bring it over and make it negative. And now use the quadratic formula, okay? So here we go. Now here we go. And c equals negative e. Alright? Now here we go. Negative b plus or minus the square root of b squared minus 4 a c, okay, all over 2a. Okay, negative times a negative is positive 1 plus minus, okay, negative 1 squared is 1, and then negative 4 times 1 times e is positive 4e, all over 2. Okay? Now I'm going to go ahead and make this thing here a big decimal, okay? So here's what I'm going to do. I'm going to take the square root of 1 plus 4e. And I'm getting 3.44. So 1 plus minus 3.445740 over 2. So guys, with your calculator, if you take 1 plus this number here divided by 2, you will get 2.223. Okay? And then if you take 1 minus this big number here, you will get, hold on one second, you will get negative, if you take 1 minus this big number here, enter, divided by 2, enter, you will get negative 1.223. So it looks like we have two answers, okay? Now remember though, whenever you're solving a logarithmic equation, you must check to make sure the answers work, okay? So this answer here works just fine. This one here does, okay? But this one here does not, okay? Because look, if you put negative 1.223 in for x, right here, you have a negative argument. And that totally means this answer here can't work. You can never have a negative argument. Okay, so this is the answer right here. Okay, all right, number 97. Okay, looks like the same kind of stuff, so here we go, which will be fun. I'm kidding. All right, here we go. 97. Oh boy. Okay, let's multiply these two arguments together. You have two logarithms being added, so natural log of x squared minus 2x equals 1. There's e here. Okay, so same thing again. X squared minus 2x equals e to the 1. Bring that over and we have x squared minus 2x minus e to the 1 equals 0. Now let's see. A equals 1. B equals negative 2. C equals negative e. So negative 2. Negative 2 squared minus 4ac all over 2a. Okay, so next we'd have positive 2 plus minus 4 plus 4e all over 2. Okay? Now, let's see. 2 plus minus 4 plus 4e square root of that 3 points. We have 2 plus minus 3.856569 all over 2. So if you take 2 plus this big number here, this big decimal number, and divide it by 2, you will get 2.928 for one answer. Then take 2 minus this number divided by 2, and you will get, hold on 1 second here, you will get a negative number. I'm not sure exactly what it would be. Let's see here. It'd be 2 minus 3.856569 divided by 2, you get negative 0.928. Okay, now those are your two answers as long as they both work. And I can tell you now, this one here is not going to work, okay? Because this answer here is going to make one of your arguments negative, okay? And here it is, number right here. Right here for this x here, you put negative 0.928, which doesn't work. So the only answer is this answer here, okay? Moving on to number 99. Now, students, first of all, understand something here. We have one log on one side and two logs on the other side. Okay, so here's what we're going to do. We're going to go natural log of x plus 5 equals natural log of x minus 1 over x plus 1, because these two logarithms here are subtracting. Okay, now when you get it down to one logarithm on each side like we have here, look what you can do. You just simply cross off your logarithms and set the arguments equal. So to get rid of this fraction here, I'm going to multiply both sides by x plus 1. Okay, over here they cancel out, leaving you with x minus 1. Over here you would get x squared plus 6x plus 5. Okay? Now bring the, let's see. Is that right? Positive 5. Yeah, that's right. Now bring the x over and make it negative. Bring the 1 over and make it positive. And we're left over with x squared plus 5x plus 6. And thankfully, that can be factored, okay? X plus 3, x plus 2. So take each group and set each group equal to 0. And x equals negative 3 and negative 2. Now let's see if any of these don't work, okay? Let's start with negative 3. Put a negative 3 here, we're good. Put a negative 3 here, and we're not good. No good. It gives you a negative 4 for an argument. Negative 2 also doesn't work because a negative 2 here for x gives you a negative 3 for an argument. So none of these work. So your answer is for 99, no solution. All that work for no solution, okay? Alright, moving on to 101. Oh, almost done. I got a headache. Alright, here we go, 101. Here we go. Well, I mean, the logarithm's all by itself, so z minus 3 equals 10 to the second power. Z minus 3 equals 100. Z equals 103. Pretty simple. Okay, moving on to number 103. Alright, here we go. Divide both sides by 6. So log base 3 of 0.5x equals 11/6. Okay? Now write that exponentially. So 0.5x equals 3 to the 11/6 power. And then divide both sides by 0.5. 3 to the 11/6. Like this. So with your calculator, type in 3 to the 11/6 power. So 3 arrow, like this. 3 arrow, parentheses, 11 divided by 6. You gotta put that parentheses, okay, guys? 11 divided by 6, enter, and then divided by 0.5, enter. And you will get the right answer, which is 14.988. Okay? 14.988. Okay? Alright, number 105. Here we go. Alright, we have two logarithms being subtracted. Log base 10, x plus 4, over x equals log base 10 of x plus 2. Okay, cross off your logs. And here we go, multiply both sides by x. These cancel. X plus 4 equals x squared plus 2x. Okay, bring the x over and make it negative. Bring the 4 over and make it negative. Okay, so we're left with x equals, or let's see, no, I'm sorry, that's not correct. 0 equals x squared plus x minus 4. Okay? Now that's number what? 105. Now for 105, we're going to have to use the quadratic formula because we cannot factor this. So, here we go very quickly, and I do mean quickly. Here we go. Negative b plus minus the square root of b squared minus 4ac over 2a negative 1 plus minus the square root of 17 over 2. And that would give you these two answers right here. 1.562. And the other answer is negative, I believe. Yes, it gives you a negative number. I'm not going to worry about that. So it doesn't work because you can't put a negative number in for x right here. It would make your argument negative. So this answer here does work. It works here, here, and here. So that is the answer. Okay, number 107. Here we go. 107. Two logarithms are being subtracted. So log base 4 of x over x minus 1 equals 1/2. Next, we're going to write it exponentially. Okay, like this. And now, guys, real quick, 4 to the 1/2 just means square root of 4, which is 2. So I'm going to very quickly make this easier and call that a 2. Okay? Now multiply both sides by x minus 1. And we will get x equals 2x minus 2. Okay, bring this 2x over, make it negative. 8 of x equals negative 2. X equals 2. Okay, that's number 107. And 2 does work in all of the arguments. So we're good. Okay, so one more, 109. And we're finally done. And here we go. Okay, we got log base 10. Log base 10. Subtracting, so log 8x over 1 plus x to the 1/2. Okay, equals 2. So next I would have this. There's a 10 here. So 8x over 1 plus x to the 1/2 equals 10 to the second. Okay, writing it from logarithmic to exponential. So next I would have 100 here. Now I'm going to go ahead and flip both sides. Make it easier. So I'm going to have 1 plus x to the 1/2 over 8x equals 1 over 100. Okay, multiply both sides by 8x. And I would have 1 plus x to the 1/2 equals 8x over 100. Okay, now multiply both sides by 100. And I would have 100 plus 100x to the 1/2 equals 8x. Okay, alright, now I'm going to go ahead and make this entire equation a little smaller by dividing everything by 8, just to make it easier. So now I have x, 100 divided by 8 would give me 12.5. And guys, I'm sorry, that's not correct. Sorry about that. I would want to divide everything by 4. I'm going to reduce everything by 4, not 8. So I'm going to reduce everything by 4, okay? So 2x. There we go. It's a lot better. Sorry about that. There we go. Now, guys, x to the 1/2 means, don't miss this, okay? X to the 1/2 means square root of x. Okay? Now, if I want to get rid this radical, I gotta square both sides. Here's what I'm gonna do. Bring the 25 over, make it a negative 25, okay? So now I have 25 equals 2x minus 25. Like that, okay? Now, when we square this side, to get rid of the square root, we have to square this side over here. Now, when we square this side here, we're going to get 4x squared minus 100x plus 625. Okay? Now when I square this side over here, I have 25 square root of x times 25 square root of x. Okay? Well, 25 times 25 is 625. It's square root of x times square root of x is x. So I get 625x. Okay? Now bring that over and make it negative. And I'm left with 0 equals 4x squared minus 725x plus 625. Now, unfortunately, that cannot be factored, okay? So we're going to have to use the quadratic formula, which really makes me about want to cry, but I'm not going to, so here we go. So here we go. Negative is 725 plus minus the square root of 725 squared minus 4ac all over 2a, 2 times 4. And we can continue on and on. The bottom line is this, guys. In the end, you get out this answer here. And I'm looking right in the back of the book. Okay, guys, everything we've done here is perfect. It's exactly right, okay? You get out 0.866. And you get out 180.384. Okay? Now this is extraneous here. Because if you look, guys, if you put this right here in for x, no, maybe not. Let's see if that works. Hold on one second. Looks like they both work, actually. Let's see. Yep, they both work. So there we go. Okay? So there's the answers. And a lot of work. But that's the answers, okay? I hope this homework help video has been a help to you guys. If you have any questions, don't hesitate to call or email.